Now we'll see the control bits of IO devices and processor which are going to help us in implementing interrupts. So one important bit is interrupt enable bit. Every device can have this kind of interrupt enable bit. Initially, let's say generally they will be zeros. Okay. So whenever these IE bits are zeros, then they cannot generate any interrupt. Now any program wants to take the interrupt from the devices, then they can make them ones. Okay, such a way we have to write a program. This is one of the design. So there are other designs possible. Okay, so I'm not discussing all of the designs because there are various architectures possible. That's why we are just understanding how interrupts can be implemented in one way. Okay, but there can be other ways, don't worry. Now similarly CPU also, this your processor will have IE bit that will be 0 initially. Now example, currently one program wants to, I'm going to help you interrupt enable, I'm going to explain you how this interrupt enable bits can be used by your program. Example, you want to write a program, currently that program is loaded at 5000, okay. Now, I'm just teaching you how to implement a program so that that program can take, that can take only interrupt from keyboard, simple. For that program should write instructions that should have instructions such a way that so that interrupt enable bit of CPU that should make 1. Such a way we have to write a program. Now after that keyboard's bit that IE bit should become 1 and all others are zeros. Okay. Such a way if your program modifies the bits, then what happens, you see, really if your program does that, then only keyboard can generate the interrupt and CPU is ready to take the interrupts. Now, sir, actually I don't want to take any interrupt, sir. Simple. Then make CPU bit that IE bit 0. That's it. Now your processor cannot take any interrupt. In that way, your program will be interrupt safe. Okay, it's all up to you how you want to do. Now, second thing. Example, let's say you don't want to allow nested interrupts. Nested interrupts. What is nested interrupt? When you are executing, that means one interrupt is getting executed and you don't want another interrupt. Okay, then we say that, so no nested interrupts. Okay, how to implement no nested interrupts, sir? Very simple. Example, you want to take only interrupts from keyboard, not from anything. Okay, simple. So you write a program such a way that make IE bit of keyboard 1 through your program and make other bit zeros. Then what happens? Then only keyboard can interrupt. Okay, let's start. Now let's say at this moment you have written a program which is currently executing at 5000. Now eventually your program counter value become 5008. Suddenly interrupt came from keyboard because that is expected. Keyboard has to give the interrupt. That is what you are expecting because its IE bit is 1. Then it will generate an interrupt. When it generates interrupt, then what happens? This is, let's say, keyboard's interrupt service routine. We know one thing. So this interrupt controller will be designed such a way that automatically your program counter's value will be stored in link register. Did you remember? Link register 5008. Then happily your program counter will be modified to what? Interrupt service routine's address. Let's say it is 1000. Correct? Then automatically your processor will execute interrupt service routine. So there will be end of the instruction which is nothing but return from interrupt. Because of that instruction, then automatically this link register data will be transferred here. Correct? So that is the way interrupts will work. Now nested interrupts are not possible in this model. Correct? Because we are not allowing others to interrupt you. And one more thing you remember, whenever you started servicing that keyboard should not generate another interrupt. Correct? Correct. So then it will become again nested interrupt. Since you don't want nested interrupts, you can do one thing. Whenever keyboard generates interrupt, then this circuit, okay, so what it is making? It is changing the program counter to the starting address of interrupt service, right? Then in the interrupt service, what you can do is, while servicing this keyboard, it should not generate another interrupt, right? Immediately you make this keyboard's bit 0, IE bit. Then what happens? Then no further interrupts are possible from the keyboard. In that way, we can restrict that keyboard to generate only one interrupt. Second alternative, sir, can I do one thing? What is that? I don't touch this bit, but whenever a keyboard generates an interrupt, because I want only at most one interrupt, I don't want nested interrupts, then can I make this CPU's IE bit 0? Yes. If you make this CPU's IE bit 0 through your interrupt service routine, then what happens? then other interrupts cannot be possible while you are executing your interrupt service routine. In that way, so we can execute, we can implement this kind of model. Sir, but I want nested interrupts, sir. If you want nested interrupts, what we can do, I will tell you. If you want nested interrupts from, let's say, assume that from anyone, okay, then what you do is, initially you write a program like this. So in the program counter, initially it is 5000. Let's say you design your program such a way that, let's say this is your program. Make CPU bit 1, IE bit 1, okay, because you want interrupt from everyone. Go to all the device registers and make IE bit 1. Such a way you write a program. But then what happens? Now every device is ready to create an interrupt or generate an interrupt. Now you want nested interrupts. That means interrupt when you are servicing the interrupt, right? Let us see how it is possible, like why it is possible, we'll see. Example, let's say first time, let's say keyboard generated an interrupt. When keyboard generate interrupt, then what happens? Your interrupt controller will do what initially? It will change the program counter to what? This one, right? Starting address of this interrupt service routine. Already we have seen that model, right? Assume that, let's say that is 1000. Through that vector table, did you remember? Through interrupt service routine table, interrupt vector table. So we pick the right address. Okay, fine. Everything is fine. After that, you execute interrupt service routine. While you are executing interrupt service routine, another interrupt might come. Then what to do? You should be very careful, because so far you are assuming what? Did you remember? We were assuming only one keyboard, one device interrupts you. What if multiple devices interrupts you? What's the problem, sir? What is a big deal in this? Because you are using link register to remember the return address. After this, in the link register, what were you writing? Example, let's say initially it was 5000, right? Correct. Then once interrupt is done, you thought of going to 5004. That's why you stored the next address of the program here, right? So once interrupt service routine is completed, you wanted to go to 5004. But the problem is, if the nested interrupts are allowed, when you are executing this program, one more interrupt comes. Then control should come to, example, let's say another interrupt service is at 3000. Okay. Then what should I write? So what is the model of interrupt? Then we write like this. In the program counter, we keep 3000 so that we can serve the next interrupt service routine. But this link register is 5004, right? So where should I return after this completing this interrupt service routine? 5004? No. I was doing in some of the interrupt. This program is not done. Then once this second interrupt service routine is completed, I should go back to this one. Correct? So that's why this single link register will not work. It's like nested function calls, correct? Then what you do is maintain a stack. I am showing outside of the memory, but it is part of the memory. There will be a stack pointer. So we have to design interrupt service routines such a way that nested interrupts can be supported. How I will tell you. Initially, what you do is, one first interrupt comes, then the interrupt service routine should push all the data. Where to go back after this interrupt service routine? What is the program counter? That program counter is 5004, right? Next address, okay, return address. That return address should be pushed into the stack, okay, remember, and some other details. I will tell you what is that other details. After that, if another interrupt comes through another device, then where you wanted to go because of that 3000, correct? Then what you do is, what were you doing at that time when interrupt came? Let us say when the second interrupt came, you were executing here. That address is, let's say, something 1010. Remember like this, okay. After 5004, I should go to, before that I should go to 1010. Then execute this interrupt service routine. Sir, while executing this interrupt service routine, I am at 3008, but interrupt service routine is not completed. What if another device generates interrupt? No problem. What you can do? Example, let's say that interrupt service routine is at 7000. Okay. Then simply push this next address. In this interrupt service routine, where are you? 3008. You push 3008 also into the stack. Okay. Now, finally, when this interrupt service routine is completed, then we have to pop. That means you have to design your program such a way that this 3008 should be popped and program counter should be loaded with 3008. Fine. Okay. Then blindly that processor will execute this program, right? While executing this one, once this interrupt service routine is done, there will be return from interrupt, right? So whenever this return from interrupt is executed, what that return from interrupt should do is, it should pop one more return address, this time 1010. So because of that, control comes here. That means in the program counter, I am not showing the program counter, but in the program counter you have to write 1010, right? Such a way that return from interrupt should be implemented. Okay, because of that, what happens, will come here and we execute like this. Then here also there is a return from interrupt. What this return from interrupt should do is, it should again pop from the stack, this time 5004, then it should store 5004 in the stack, sorry, in the program counter. Because of that, we will come to the normalcy, right? That means normal execution. In that way, yes, we can implement nested interrupts, right? The only thing is, the return from instructions, return from interrupt should be properly implemented. What they should do, they should get the next address from the stack. Second thing, so this, whenever a new interrupt comes, that interrupt service routine, example, let's say suddenly you are executing a new interrupt. Whenever you are executing new interrupt, so that means what, you are executing one interrupt service routine. I show here clearly. So there are two steps, step 1, step 2. So this is your interrupt service routine. Okay. Currently program counter is showing something 7000. What I want to tell you is, for proper execution, this program counter, let's say next address is 7004. Okay, that means we have to come back to 7004. Then in the stack, we have to push 7004. Who should do it? We means what? That interrupt service routine, in that we have to write the first very instruction like this. That means push the program counter into stack pointer. Okay, rather than link register. Okay, now next time. Now while executing this interrupt service routine, another interrupt comes. Let's say that interrupt is here. Okay. In that interrupt service routine, the very first instruction should be push current program counter. Example, let's say next program counter may be 8000, in that way. So all the interrupt service routines should push the next program counter address into the stack, like function calls only. Okay. Now, if you do that, and when every interrupt service routine should have return from interrupt, okay, return from interrupt instruction, RFI. So what should be the work of that return from interrupt? Return from interrupt should pop from the stack pointer, so that we will happily go to exact execution, correct? In that way, so nested interrupts are possible if you carefully design your interrupt service routines. Okay, now you don't really require any hardware support, right? So only you require is this IE bits, correct? So that's why, so without much hardware support, we can easily we can easily implement nested interrupts, correct? So this is the way. So one very key role is this stack pointer, correct? The stack pointer is playing very important role. If you don't have stack pointer, then these nested interrupts generally very difficult to implement, correct? It is not possible, I can say, right? So this is about interrupts, right? Finally, you understood about nested interrupts, single interrupt. Single interrupt mechanism is easy, correct? Now for nested interrupts, what we have to do? We have to make IE bits 1 first, right? The program which wants to have nested interrupts, that should make IE bits 1. Sir, but in nested interrupts also I want restriction. What is that? One interrupt, example, let's say I'm executing a program. That program called, because of that program wants every interrupt from every device. Okay, then suddenly keyboard gave the interrupt. Let's say now currently I'm executing interrupt service routine of keyboard, but keyboard only wants interrupts from this one, this register. What is the device? D3, not from D2, sir. Then what to do? Simple. In this interrupt service routine, the first very instructions, you have to implement this interrupt service routine such a way that should make, you want only from D3, right? That interrupt service routine should make this IE bit to 0. Then what happens? Only this and this can generate interrupts. In that way we can plan, not a problem. These are all the details about interrupt service routines and interrupts, and how the interrupts generally can be implemented. Now we will see the hardware aspect in the next sessions. Okay, once memory management is done, once pipelining is done, then I will be teaching you how to design the circuitry like this to have to have interrupt mechanism. We will see that later. Here only we have seen programmer perspective, generally how implements are implemented. Okay.